This audio is about Coriolis Force. When living in London, commuting by bus is almost a fundamental way of life. And if you have taken the bus before, you must have felt the sudden jerk when the bus starts moving or be swung sideways when the bus takes a sharp turn. This becomes more obvious when you are sat on the upper deck. This is all caused by a fictitious force felt only by masses like us the passengers. Before we continue, here are two definitions that you need to know. An inertial frame. An inertial frame has no acceleration, and it is either stationary or moving at constant velocity, such as your brain, in coma after studying classical mechanics. A non-inertial frame. A non-inertial frame is one which is undergoing accelerations, and so it does not have constant velocity, that is the accelerated bus as a frame of reference. We've all encountered this concept in classical mechanics last year, where we are taught these equations. In this video, we are going to only focus this, the Coriolis force.
The Coriolis Force. The first thing we need to understand about the Coriolis Force is that it is a fictitious force. It only exists when described in a non-inertial frame. It cannot be felt by masses that are observing from an inertial frame. Although it cannot be felt from the outside, it is in fact observable. As you can see below, the green roundabout rotates anti-clockwise. Now imagine you are standing in the middle, holding a basketball. The world around you is spinning and you pass the ball to a friend standing outside the roundabout. You try your best to throw the ball forward as your friend whisks by in front of you. From your perspective, the ball took the path in blue, even though you threw it straight. However, from your friend's perspective, the ball took the path shown by the orange arrow. The orange path that has been observed by us who are at rest is the trajectory of the ball in an inertial frame. This means that the ball has a zero net sum of forces. The ball came from the middle of the roundabout, a point where there is no angular momentum, which means that the ball does not experience any forces initially. As the ball travels further from the center, with only its forward velocity, it is unable to keep up with the anti-clockwise spin of the roundabout. Therefore, there is a fictitious push towards the clockwise direction acting on the ball to maintain its straight path in the inertial frame. This push is the Coriolis force in action.
The maths. Taking a look at the formula, we can see that the magnitude of the force is dependent on the angular velocity of the rotation of the non-inertial frame, as well as the velocity of the moving mass. The cross product is used here, as we know that the direction of the Coriolis force is parallel to the plane of the rotating body and perpendicular to the velocity of the traveling mass and the direction of angular velocity.
The following problem is taken from the second ICA of 2017 and 18 classical mechanics. I suggest that you can take a pause to read the question first. The highlighted words or phrases will help you to understand the question better. The thought process to do this question starts with identifying what physics concepts that we are dealing with. First, we know in the rotation system, the Coriolis force is equal to minus 2 omega cross product velocity. From the picture, we see that there are two frames of references. One is a carousel, which is the non-inertial frame of reference, and the other one being the Cartesian system on the top of the carousel. The ball is being thrown along the y-axis. The angular velocity of the carousel is represented by a vector omega that is moving in an anti-clockwise direction with respect to the fixed Cartesian system. The velocity of the ball is shown to be parallel to the y-axis and perpendicular to the angular velocity of the carousel. Therefore, the absolute value of Coriolis force is omega multiplied by velocity, and its direction is anti-clockwise. The angle between the force and a verifying velocity of the ball is 90 degrees. In terms of work done, there is no work done on the ball as the direction of the ball's speed and Coriolis force are perpendicular at all times. Thank you for watching this video.